All right, here we go, 4-2A, and this happens to be the second time I've gone through this video because the first time it didn't take, and it's a little crazy here. What we're going to talk about today is primarily about the pi over 6 and pi over 3 angles. Okay, now I wish I had really a lot of time to go over these negative coterminal angles or explain the difference between linear and angular velocity, but I really don't if I'm going to keep this particular idea into a doable video that you guys want to watch. Now, the first thing I'm going to basically talk about here is a little triangle review, and then I'm going to push this triangle review onto your unit circle in just a second. Okay, so make sure that your unit circle is somewhere close by. Now, what I'm going to talk about is the 30, 60, 90 triangle. And the first time I draw this 30, 60, 90 triangle, I'm actually going to draw it 3 separate times. I'm going to draw it the good old-fashioned way that you learned when you were in geometry. It's the 30, 60, 90 triangle. And you probably will remember that the references of the sides back in honors geometry or formal geometry was the fact that the shorter leg, oops, sorry, I got that backwards. I drew it out of proportion. Let's do that again. The 30-degree angle and the 60-degree angle. I'm going to draw it this way, sorry, to make it so that it looks really 30 degrees, and this one looks really 60 degrees. The 30, 60, 90-degree angle would happen to be that this side, the smaller leg, was 1, the side of hypotenuse was 2, and this one was the square root of 3. Okay, now that is a good place for us to actually start, but the problem that I have with that particular triangle is the fact that the hypotenuse in this case is 2. But I want to make the hypotenuse in it, since it fits in a unit circle, to be 1 in terms of its size. Now, and also, I want to really think about the fact that this 30-degree angle one that's listed down here, I will call it 30 degrees, that's fine, but it has a radian amount that's associated with it, which is pi over 6. Now, you could get that by doing your conversions and so forth, but ultimately, that's what this one would turn out to be. Now, this is the exact same 30, 60, 90 triangle, but if the actual side over here is 1 for the radius, being that it's a unit circle, that would make this one 1/2 and this dimension root 3 over 2. Okay, now it's the same exact triangle, just the radius happens to be 1. And I did that on purpose because this coordinate is going to be the coordinate that's going to show up on your unit circle, which is going to be x amount one way, root 3 over 2, and y amount going up, which is going to be 1/2. Now, I drew that one on purpose to be the 30-degree one. Now I'm going to draw the 30, 60, 90-degree angle in this triangle with, instead of the 30 being in the corner, the 60 being in the corner, or pi over 3 angle. Now, that one makes this one the small one, or this is the hypotenuse. This is the small one being 1/2, and that would make this one root 3 over 2, or better yet, the coordinate at the top being 1/2 and root 3 over 2. Now, the only difference between those two concepts is that the actual coordinate has switched places and it's flip-flopped itself. Now, those two, and they're color-coded on purpose, are going to now make their way to your unit circle to see what's going on. So flip to your unit circle now. Now, this is what your unit circle should look like from the previous unit. We've only actually discussed how to do the 45-90 triangle, all right? Now we're going to tackle the 30-degree angle one, the one that's sitting on this particular spot right here, or the 30-degree angle, or the pi over 6 angle that's in that spot. Now, we actually came up with that. This one was 1. This right here would be the shorter leg, which would make it 1/2. And this dimension right here would be the root 3 over 2, making this coordinate root 3 over 2 and 1/2. That's the coordinate that goes in that particular spot. Now, the really cool part about all of these pi over 6 angles is very similar as they were to the pi over 2 or 4 angles. They turned out to be root 2 over root 2 and then root 2 over root 2 on the other side and so forth. Well, every pi over 6 angle, which has got a 30-degree reference angle, is going to have the exact same coordinates, but it's just going to change signs as it goes into the next quadrant. Now, what I mean by reference angle is that this one is going to be the pi over 6 reference angle that's exactly the same size, the little guy that's the same size to the x-axis. That would mean that this angle on this side is a pi over 6 answer as well, or 5 pi over 6, and it happens to be 30 degrees shy of the 180, which makes it 150. And the answers to this would be root 3 over 2 and 1/2 as well. But since it's in the second quadrant, it would be negative in x and positive in y. So this is a negative root 3 over 2 and a 1/2. Now, I'm doing these in the same color, and you probably should too. Color-coded if you're one of those special people that likes to do that. Here is the same 30-degree reference angle in this one going down here to this point, and that's the 30-degree angle, which means that this must also be a pi over 6 answer, which happens to be 7 pi over 6. And it'd be 30 degrees more than 180, or 210. But the answer would still be root 3 over 2 and 1/2. But since it's in the third quadrant, both of those answers would be negative in that location. Now, do you see how I'm using the same 30, 60, 90 degree triangle, or the 30-degree angle, pi over 6, in each reference deal? This is a little reference angle that's telling you that that's a 30-degree angle concept. That would make this one 11 pi over 6, because it's pi over 6 shy of 2 pi. And that would be 30 degrees shy of 360, which would make it 330. And again, it would be the same answers of root 3 over 2 and 1/2. But since it's in the fourth quadrant, it's positive x and negative y. And that would be the answers for the pi over 6 locations. Now, I'm going to pause this now, and I'm going to go back to our actual deal and talk real quickly about the pi over 3. Now, what I want you to notice on these pi over 3 ones, or the 60-degree angle topics, was that the fact that the coordinate, all it did was, compared to the one for the pi over 6, was it switched places, and it became 1/2 and root 3 over 2. Now, that's exactly what's going to happen on all those pi over 3 angles, or 60-degree ones, that are going to be just past 45. Now, we're going to go to our unit circle, and we're going to put in all of those particular coordinates. I know it's back and forth, so just be patient. Now, I got a lot of little lines that are going on inside here, so I'm going to kind of erase some things that might be a little bit like crazy for us and everything. So let's talk about the 60-degree angle one, or the pi over 3 angle. Now, that guy is going all the way out to this one, which would make it a 60-degree angle. We got it right there. And this one is at pi over 3 is what the radian is. And again, all it does between the pi over 6 to pi over 3 is flip the two. This is the smaller, shorter 1/2. And this is the longer root 3 over 2. So this becomes 1/2 and root 3 over 2. And that's going to be exactly the same for every 60-degree angle that's measured as a reference angle to the next following one. So this is the 60-degree angle, or 120, or it's going to be a pi over 3, which would be 2 pi over 3, and that's going to be 1/2 and root 3 over 2. But since it went negative into the second quadrant, then positive, it would be a negative 1/2, then the positive root 3 over 2. Now let's go to the third quadrant and get that one. Now, this is going to be an over 3 deal, and that's what you really got to start recognizing, is that over 6 is 30, and over 4 is 45, and over 3 is 60. Get that in your mind. This is going to be 4 pi over 3, and 60 degrees further, which is 240, and then this is going to be 1/2 and root 3 over 2, but since it's in the third quadrant, it's negative and negative. And then I'll go over here to this 60-degree reference angle. Sorry, I didn't show them in that one. This one right here would be 60 shy of that, which is 300. It's an over 3, which is 5 pi over 3. And that's, again, going to be the 1/2 and root 3 over 2. But since it's going positive then negative, this is the negative 1. All right, now, if you get to this point and you're like, okay, I got to look at all that stuff, go forward and backward in the actual video and make sure that you get your unit circle completely filled out. Now, I'll pause right here so that you got a little bit of a moment. All right, now, the hardest part that I can probably say to you that Trig is going to be about at this point in time is the fact that you're going to actually now be asked to focus on coming up with some answers to specific trig values. Now, what they're really meaning here is that you've got to come up with an actual answer to cosine of pi over 6. Okay, now cosine of pi over 6 is asking for the x component of cosine. Cosine's for x and sine is for y. That's a good thing to remember. And then they're asking what is the x component of the coordinate at the pi over 6 location. Now I'm going to use these up here as my reference because I don't want to go back to the unit circle. So this is my pi over 6 deal. This is the coordinate that's at that spot. And I'd realize that the answer would be root 3 over 2. Now you could look it up on your unit circle, go to the pi over 6 line, go all the way out to the coordinate, find the x piece. Now this one's asking what's the y component of that coordinate over there, and the y component would be the number 1/2. Okay? Now it turns out the tangent at pi over 6 happens to be a little bit of a weird deal, and that one happens to be root 3 over 3, and that's because you put the y over the x and you would rationalize it. I really don't have a lot of time to show that, but this root 3 over 3 comes from the fact that it's 1/2 divided by root 3 over 2. I guess I have enough time, which is going to be 1 over root 3, and rationalized, that would be root 3 over 3. That's where that answer comes from. Now, I'll show you an easy way to remember that, too, as well. Okay? Now, cosine of pi over 3 is going to use this one over here and this coordinate, and it's looking for the x amount of that coordinate up there, which would be 1/2. And sine is looking for the y part of that coordinate, and that would be root 3 over 2. And if I put y over x for this one, I would end up with the answer of root 3 over 2 over 1/2, and the halves cancel, and you get root 3. And I'll show you an easy way to remember that. Now, here's the deal, and this is kind of like the breaking point. As you go around the unit circle, you're going to probably be like, how am I going to be expected to remember all of the different coordinates that are on there, and how am I supposed to be able to come up with those trig values at those particular spots in a relatively timely manner? Now, I will be able to convince some of you not to memorize your unit circle. Some of you will be just like, gee, this is the easiest way for me to memorize the unit circle. Okay? I'm not that kind of person. I can't memorize the unit circle. I'm getting older. I forget things. So does Mr. Leesman. And, as we will, Mr. Naughton, he can't remember anything. Okay? Only one person that's good is Miss Babbitt. Now, I had to come up with some other kind of mnemonic that ended up making it easier for me to remember what is going to be the answers. Now, it turns out when I start looking at all the different coordinates that are out there, it was either like a 1/2, or it was a root 3 over 2, or it was a root 2 over 2 is the way that those coordinates kind of tended to turn out. Okay? And what was really the only difference between any one of these three concepts right here was the fact that the numerator was the only part that was really changing. The bottom was always over 2. So a really simple mnemonic to help you remember it is that sine is 1, 2, 3. You can count 1, 2, 3. And cosine is 3, 2, 1. All right? Now, you're probably like, what the heck does that mean? Well, the way I wrote it out here is 1, 2, 3 and 3, 2, 1 is specifically speaking to what the numerators will be. We know it's going to be over 2. And then you're like, why is it in this specific order? Well, the first column of these represents the pi over 6s. This is your pi over 6 reference angles. The middle column is your pi over 4 reference column because it's 30, then 45. Then this one is your pi over 3 reference concept. And it's telling you what the numerator is going to be. Now, this is a really easy thing to kind of remember, and I'll show you how to use it in just a second. And then the last concept is you would use this in conjunction with, because you got to get the sign right, it would be in conjunction with ASTC. And this tells you exactly what the signs are supposed to be in each individual quadrant. All right, now let's put this to reference so you can see how to fill out your chart. Now, these are pi over 6 angles. All of those are pi over 6 reference angles, and they will exclusively use this column right here. That's the only column that's going to even matter here. Sine is going to be a 1 concept, which means that every single one of these sine ones going down the deal is 1/2, 1/2, 1/2, 1/2. It's the 1. It's telling you that they're going to turn out this way. Now, that's not the right answers just yet because it hasn't got the right signs on it, but they're all going to be 1/2. The cosines in that pi over 6 column are all going to be √3/2s because it's a 3, 2, 1 concept. It's the 3 in the pi over 6 reference angle. √3/2. Now check that out. I got all those answers relatively quick and didn't have to look at the unit circle to get those concepts. Now the problem is, what's the sign supposed to be on them? Well, in the first quadrant, everything is positive. Those are positive. In the second quadrant, only sine is positive, so cosine would be negative. In the third quadrant, only tangent is positive, so these would both be negative. And then last but not least, in the fourth quadrant, cosine is the only one positive, and sine would be negative. So you can use ASTC to help you come up with the signs, okay? Now, how do you come up with the answer for tangent? Now, tangent is like a weird answer of what it is, but the easiest way to remember is that we're talking about pi over 6, and the answer for tangent is √3/3. Notice that it's an over 6 concept, and these two things add to 6, okay? That's how you know that every answer is √3/3 all the way down this deal. Okay, √3/3, √3/3. Now, I don't know, Mr. Leesman might do it a different way, but I think that's the easiest way for me to actually remember. Pi over 6s are for tan, and if you want to expand this chart, √3/3, and for pi over 3, it's √3, and this one's 1. That's the hardest line to remember, but that's basically the full idea. Now, what would the signs be? Cosine or tangent in the first quadrant is positive, second quadrant it's negative, third quadrant it's positive, and fourth quadrant it's negative. There's your answer. ASTC gives it away. Now, how do you fill out the rest of this chart? Well, everything in the rest of this chart is just a reciprocal of what was in the previous part of the chart. Secants are really 1/cosines, or their flip. Well, what would all these flipped cosines be? Well, if you put the 2 on the top and the √3 on the bottom, it rationalizes to 2√3 over, oh, no, wait a second, let me think about that. 2√3/3. That's what all of these are. all the way down the deal. 2 root 3 over 3 and 2 root 3 over 3. Now, I don't ever memorize these. I always look at what cosine is and figure out what it should be. The signs will be exactly the same. Negative, negative, right here for those. Cosecant is the same as sine flipped over. Oh, those are all 2's. That's really easy, and the signs will match there too as well. Cotangent would be this guy flipped over, which would rationalize to root 3's. It's kind of like the opposite down here. These two are opposites of each other, and the signs would match on those two particular concepts. And that's how you get your reciprocal other 6 trig functions. Now, that's exactly how I would fill out the pi over 6 chart. The pi over 3 chart, which comes down here, would work the exact same way, except that in the sine is 1, 2, 3 and cosine's 3, 2, 1, I would now be working in this column because I'm working with the pi over 3 concept. Well, that would mean that sines all have 3's on the top, and that would mean that they're all root 3 over 2's all the way down. Oh, I got to move this just a little bit. Root 3 over 2. And all of the cosines would be 1/2 all the way down. And ASTC would tell me exactly the same thing based on signs. All positive, second quadrant, only sine is positive. That one's negative. Cosine is positive, and they're both negative in the third quadrant. And then the fourth quadrant, only cosine is positive and sine is negative. Now, you see how quick you can get those answers? Tangent, on the other hand, would now be in this column, which is going to be pi over 3. So its answer is root 3. Remember how the other one was added to 6 and it made 6? This one is 3. So these are all root 3's, which probably means that all the cotangents are root 3 over 3's because they're completely the opposite. And secant and cosecant are going to be the flips of those. Now, cosine would be all these are 2's. And the secant one, this cosecant one would be the sine flipped over, which is the 2 root 3 over 3 concept. 2 root 3 over 3 and 2 root 3 over 3 and 2 root 3 over 3. Now, the problem is I got all the signs wrong on all that stuff, so we got to make sure that ASTC is right. Positive, negative, positive, negative. Okay, that's right. Secant's going to be the same as cosine, so these two are negative. Cosecant's the same as sine, which is these two are negative. And cotangent's going to be the same as tangent, which is this one and this one are negative. And check it out. I filled out that chart, and here's the cool thing, guys. Did I ever look at my unit circle? Did I look at the unit circle to do it? No. I didn't memorize the unit circle. I memorized a simple mnemonic. And that is the key to being good in trig. Now, let's see if I can actually come up with some answers here and combine some answers to figure it out. Now, your values at home, and you took your table and you color-coded it. I'm sure you did. You're going to want your unit circle no matter what. It's a good reference material. Your mnemonic is great too as well. And we're going to come up with some answers for these coterminal ones that are out there. Now, remember, the period is 2 pi for all the sine and cosine partnerships, even cosecant and secant. Those are all 2 pi. Pi is the period for tan and cotan. So those are from the previous unit. So if I look at this like sine of pi over 3 plus 4 pi, dude, that's just extra revolutions. This is 2 extra 2 pi's. So that's irrelevant. All I'm really looking for is sine of pi over 3. Now, when we start thinking about it, we're thinking, okay, sine is 1, 2, 3. 1, 2, 3. And the pi over 3 is the third column. So the answer must be root 3 over 2. And pi over 3 is in the first quadrant. All students take calculus. So the answer is positive. That's how you get your answer. Okay? Cosine, pi over 6. 6 pi, irrelevant. That rotates it around to still be cosine of pi over 6. Cosine is 3, 2, 1. Pi over 6 is the first column. That's going to be kind of the hardest part you'll get to remember here. So this answer must be root 3 over 2 as well, and it's in the first quadrant, so it's positive. Okay? Now, 12 pi, irrelevant. Here's where we start seeing some of these negatives that are actually going to be applied here. And you're going to have to basically think about what negative pi over 3 really means. Well, that's going to be drawn down here. And a better answer for it in that location would not be pi over 3, but it would be 5 pi over 3 is that location. Now, it's still a pi over 3 deal. And cosine is 3, 2, 1. So the pi over 3 is this guy. So the answer must be a half. But in the fourth quadrant, all students take calculus. Cosine is positive. And that's how you come up with your answer to that. Now, as we get further along on these, you're going to start to see that they're going to mix all kinds of funky things in there. Subtracting 2 pi. This is really sine of pi over 6. Sine's 1, 2, 3, so the answer is 1/2. Okay? Pretty straightforward concept. Next guy, secant. Now, there's a negative on the outside. Leave it out there. Secant is really talking about the cosine answer, but you're going to flip it. So 1 over the cosine of, and we did the cosine of negative pi over 3, which was 5 pi over 3. So this is really negative of 1 over 1/2. And if I flip that, I would get the number 2, but the negative on the outside would make it negative 2. Now, here's the deal. That is a relatively small-looking problem. Did it have a lot of juice to get there to come up with the actual answer? Yeah, it does. You got to stop and you got to think to be able to pull these off. And more importantly, you got to practice. 14 pi is going to be irrelevant. That's going to rotate us all the way around to the right spot. Negative of tangent of negative pi over 3 would be tangent of 5 pi over 3. And tangent of an over 3 must mean that the answer is root 3. But it's in the fourth quadrant based on ASTC, and that would mean that it is negative there already, but it's got a negative on the outside, so it would really make it positive. Now, these negative radian ones, they kind of are a bummer. And there happens to be an easy way to possibly deal with a negative radian concept, and that's called the even and odd rules. Now, the even rule applies that if it turned out that the radian was a negative 1, then if it was a negative radian on the inside and it was an even function, you would be able to just delete it, and the negative radian wouldn't really matter. There are only 2 functions that this actually works on. Cosine of a negative radian, like say negative theta, whatever it happens to be, means that you could actually write it as just cosine of theta. Cosine is even, and you can just delete it, okay? If cosine works that way, so does his partnership, secant, works that way too as well. And you can just delete the actual negative radian and figure it out. So you don't have to change them or anything. Look at these. These are all cosines and secants. Every one of these can be written as cosine of pi over 3 and just evaluate it. Cosine is 3, 2, 1. Answer is 1/2. Cosine, now I hope you understand what I mean by cosine is 3, 2, 1. I looked at a pi over 3 and saw that it was the 1 concept. That's why I got 1/2. Cosine of negative 5 pi over 4. Well, that's just the same as cosine of 5 pi over 4. Now, this is the first time we've seen an over 4 answer. Those guys are the ones that are in the middle. That's the pi over 4 answers. So the answer must be root 2 over 2. And since 5 pi over 4 is in the third quadrant, all students take calculus. would mean that's negative. This would be the same as cosine of 5 pi over 6. And that's just deleting that concept. Ultimately, cosine is 3, 2, 1. That's the pi over 6 column. The answer would be root 3 over 2. And since 5 pi over 6 is in the second quadrant, all students means that only sine is positive, but cosine would be negative. Now, every one that you get down here is just a secant concept. It just takes off the negative radian. But the problem is that you're thinking about it really as cosine, but then you got to flip it to come up with this answer. Well, cosine's answer would be root 2 over 2 for pi over 4. But if I flipped that, I would get 2 root 2 over 2, which is just root 2. And you could look it up on your chart if you wanted to, but that's going to be the answer that you're looking for. Secant of pi over 3 would end up being cosine is 3, 2, 1. So it's a 1/2 really, but flipped would be, you're thinking 1/2, but flipped would mean it. The answer is 2, and it's in the first quadrant, so it's positive. Pi over 6, secant of pi over 6 would mean that you're thinking cosine is 3, 2, 1. The answer is root 3 over 2, but flipped would mean the answer is 2 root 3 over 3. I think that's right. I always get that one funky in my brain. It just doesn't work right. Okay? Now, if those guys are considered even functions and they just delete it, everything else would be considered an odd function. Now, odd functions are definitely sine and his partnership cosecant, and tangent and his partnership cotangent. Those are going to be odd. Now, what do you do in an odd? Well, in an odd scenario, whatever the actual function is, we'll say it's sine in this case, of a negative radian, well, you can't just delete it like even ones are. But what you can do is move it. And you can move it to the front, and this is what an odd function does. So it allows you to look at the actual radian as a positive value, but in the end, you got to change the sign. That's the odd rule. So sine and tangent work that way. Now, if it was me, I would basically remember that cosine is even, and then everything else is odd, okay? Cosine and secant, are even, and then all the rest are odd. Now, what's this one going to be? It's really going to be sine of pi over 3, but I can't just delete it. It moves to the front is what's going to happen. Sine is 1, 2, 3, and that pi over 3 column is this one right here. So the answer must be root 3 over 2, first quadrant. You have to evaluate what quadrant it's in before you apply the negative. It's going to be positive, but then the negative would make it negative. There you go. And there's your answer. Okay? Now, cosecant would make you start thinking along the lines of sine. Okay, so you got to think like sine, but the negative is going to be moved out to the front. So we're really finding cosecant, negative cosecant of 5 pi over 4. But I'm thinking sine of pi over 4, which is root 2 over 2. It's kind of in my brain. It's what I'm thinking it's going to be. But if I flipped it, it would actually be 2 over root 2, which is root 2. So the answer is going to be root 2. But in the third quadrant, all students take calculus. It would be negative, but then I would apply the negative on the outside, and the answer would be positive. All right. Now you got to, and almost all the time you guys do these, you got to talk it out. You got to talk to yourself and figure out what the heck you're doing. And it's really going to take lots and lots of practice to figure it out. Okay? Now, tangent is an odd function, so it'd be really negative of tangent of 5 pi over 6 is really what you're finding. Ooh, it's over 6, which means the answer must be root 3 over 3. That's the one that adds to 6, right? Remember that deal? And then my answer is in the second quadrant, so based on ASTC, it would be negative, but then I've got to apply the negative on the outside, so the answer would really be positive. Ugh. Okay, that's a lot. Now, here's what I was basically saying about breaking you. I've broke you now. You're thinking about everything based on 1, 2, 3, and 3, 2, 1 of cosine being in pi over 6, pi over 4, and pi over 3. Even this tangent one, you wanted it to be in radians. Now you're probably going to look at this degree one, and you're going to be like, what the? That is a horrible question, because I don't know how to do cotangent of negative 75. You're like, that's an angle one, and unfortunately, this angle one happens to be a non-perfect or special angle one. This would be negative of cotan of 75 is really what you're trying to figure out, which would really be the negative of 1 over tangent of 75, because that's what I have to think of as cotangent. And this is calculator time. There's no way to get this angle reference in terms of its theta, because ultimately that's not a special one, and we'd have to use a calculator to figure it out. Now, to get that calculator to do its job in this particular case, you would want to make sure a couple of things are going to take place. Number one, your mode on your calculator is going to need to be in, and this is probably first time you've probably seen it, in degrees. We're going to talk about this guy being in degrees, so make sure it's flashing in degrees, not radians, because that's a degree question. And if I was going to calculate it, I'd be like 1 divided by tangent of 75 on the bottom, and that would be the radian answer for that piece, but then I'd have to tack on a negative, and the answer would be a negative 0.26 radians. And that's what theta would be in the end. So we're going to have questions where you've got to come up with the answer because they're special. And then there's going to be answers where you've got to come up with the answer because it uses that calculator. So there's going to be a lot of use here, okay? The key I would suggest, do this homework. And practice. Make your parents even come up with some random one that's over 3 or over 6 or over 4 and make you find it. Okay? There's no better way than to engage your parents, young people, and that's what you should do. All right, I hope this video helped you, and if you have to watch it again, watch it again. I'm just as entertaining the second time.